period t. So it's going to be the division between the actual forecast or actual value subtract the forecast value. And the first measurement that we're going to do is called MAD, alright, which stands for mean absolute deviation. So when you compute this, you will compute the error first, then take absolute, then take the average. Right. So for most of these terms, you start from backward. Okay, do this backward. So compute deviation, put it in absolute, then compute the mean. Alright. So the equations will be equal to the summation of absolute forecast error, alright, divided by n. Okay. So if we have this time period 1 and 2, ft is going to represent the forecast, dt will represent the actual value. You see that the et is going to be minus 5 and minus 2. Then you take the absolute, right? 5 and 2. Alright. So you compute the error, deviation. That's the first step. Then you compute the absolute 5 and 2. Then take the average. Okay, 5 plus 2 equal to 7 divided by 2, you got 3.5. That would be your MAD. Okay, so if you use forecasting model, on average, this is the deviation. That's MAD. And guys have to know how to compute this one and other ones also. Okay, there are 3 of them. Okay, the first one is called MAD. And this is how it applies the real sample. Alright, so let's say you have the data and this is a forecast. So here's the thing. Alright. So this is the data that you have. Alright. This is the actual DT and this is the forecast. So let's say you have a forecast in the first period. So there's no error. Okay. And you start having the forecast errors starting from this one until this one. Note, in the year 11, you make a forecast in year 11, but you're not in year 11 yet. Let's say you are right now, the current period is in year 10. So of course, in this one, you cannot compute the error. Alright? So you can have E2 up until E10, total 9 data points. So it means that when you compute the average, after you take the deviation with the absolute, okay, there's only 9 data points that you sum it up. So it means that your MAD is going to be 160 divided by 9, not 10, not 11. So again, we compute this average error, okay, and it should be equal to the number of errors that you can compute, not 11. Even though you have 11 here in the table, it's not going to, you cannot divide by 11. Right? So make sure you keep that in mind. Alright, so n is always going to be equal to, how many errors can you find? You can find 9, divide by 9. You can find 10, divide by 10. Don't assume that it has to be equal to this number of period that you have. Next one is going to be square error. Okay, so you compute the error, square it, and then take the average. So that's the rule. Okay. So the equations will be equal to sum of error square. You don't take the absolute, you square the error. Okay, and divide it by n. So from the previous example, okay, your ET is minus 5 and minus 2. Square is 125. Square this, you got 4. Sum it up, 39 divided by 2, you got 14.5. For MAP, okay, is the error percentage, then absolute, then the mean. Okay, so what is the error percentage? Okay, in this equation, right, it's the error divided by the actual. Okay, so this is called percent error. Once you got that, you take the absolute and then take the average. Okay. So the way we compute this is, once you find the error, okay, so this is information that we have. So your ET divided by T is going to be minus 5 over 5. Okay, it has to be divided by the actual number 5. And then this is minus 2 divided by, it's not minus 2. You have to get rid of this minus 2, sorry. Because it's 2, not minus 2. Okay, so 2 over 18. And let's go to 1 over 9. Okay. So all around 0.11, 0.11. So you sum these two up, 1 plus 0.11 over 2, which is 0.555, or around 55.5%. Right. And in general, this is the most popular one, right? MAPE. The rest you don't use it as much, okay? Most of the time, lots of books going to use MAPE to compare the result between different forecasting models. But of course, the other one you have to know it too. So maybe again, compute the error over the actual, then take the absolute, and then take the average, and then you're done.
มันไม่ใช่ต้องเป็นเลขฝั่งตรงข้าม
ตรงข้ามไหน
absolute อะเข้าใจปะถ้ามันข้างในเป็นลบข้างนอกมันเป็นใช่ปะวะ
เดี๋ยวนะเมื่อกี้หยิบตุ้มถามยังสงสัยอยู่เหมือนกัน
เดี๋ยวค่อยไปถามใจ
So you see that this chapter is all just formula. Okay, so for the term, the question from this chapter is pretty straightforward. If you don't mess up with your calculator,
ตอนนี้
so make sure you press the correct number in your calculator. So make sure when you do this, maybe you do it 2 times to double check your answer. Okay, that's the only problem that you're gonna have. Because there's so many things that you have to do, and you have to use a calculator. You can make a silly mistake, right?
เราต้องเอา
Don't, because this is where your goal line is in your midterm. Okay, so don't mess it up. Okay, it's not difficult. Make sure you got everything correctly. Okay. All right. Okay. So let me explain first, and I'll let you take note. Okay, just listen to me first. Okay. So this slide, okay, is additional. Basically, if we tell you when you should use MAD, MSE, or MAP, okay, they all follow the same rule. The smaller number, the better. Okay. So in general, we talk about when you use MAP, right? Because in this case, you don't care about the number at all. Even though it's a big or small, it can be in unit or it could be in million. You can always apply it. But when you have the error in million, okay? And you can't calculate the MSE. The error square will be around 10 to the 12. So it means that it's not going to help you very much, okay? And another problem with MAD is when you have large number is you don't know how big is the error and when the error is small. So it's very vague when we have, okay, my MAD is 1 million, my MAD is 2 million, which one is actually worse? You don't know that. That's why percentage comes in, okay? Because you can say right away that 10% is better than 50%, for example. So it's come up to when would you use MAD and MSE then? Okay, you use this when your number is in a very small, maybe from 1 to 10, and you need a perfect precision on this one. Alright? So when your data maybe in 2, 3, 1, and you want the error to be very precise, then MAD and MSE will be good. But when you have something big, never go for MAD and MSE. Always apply for MAPE. And of course, even when you need precision, MAPE is still going to work also. Alright? So that's high. Because you got from 10 to 100, you don't know that this is going to do well. But if this is very small number, you're going to like it even more. So the rule of thumb, as I say, MAPE works all the time. There's only in a few cases when you need MAD and MSE. Okay, so now you can write whatever you want. So you look in the report, not many books we report the MSE in like 10 to the 12. Okay, it's so huge. And it's pretty much useless. Compared to, I compute MAPE. It's percentage of the actual value. Okay, it has more meaning. This rule you have to understand. So in exam, if we ask you which model works better, always pick the one with the small value, not the bigger one. Okay, moving on. Alright, so let's look at time series forecasting model. Oops. Okay. Alright, so as I say, it's kind of evenly spaced events. Alright, so it's mean that we have to do monthly. You cannot do this, right? You get the data for Jan, Feb, but nothing for March, nothing for May. Okay, we can't do this. If you have to get the data, it has to be in the evenly spaced fashion. Right? So just monthly or yearly. And as I say, they predict the future based only on the past values. And you ignore other variables. You don't care, you don't look at all. Alright? So if you are the stock trader, okay, you call yourself a technical person because you don't look anything else, you look at fundamentals, you always look at the graph and then you predict if the stock is going to go up or down at what price, and then that's when you buy and when you sell. Right? Okay. And in time series, you always look at these four things, okay, which is a very important concept. So first, trend, we talk about that. Right? So there are three. Okay, you can see that they are either upward, downward, or no trend at all. Alright, so it might not have any trend at all. Okay. In stock market, we call this sideways. Okay, so we see it's going to the side and then it's not moving up and down at all. Alright, and then we have seasonality pattern. Right? Yes. So basically you can see that there's a pattern, okay, and it repeats at regular time interval. So it means that if the demand is going to go up, it's going to go up at exactly the same time every year. So for example, the forecast demand for toy is always going to go up just before Christmas. Alright? So that's called seasonality. Cycle is a pattern. It occurs every several years. For example, the oil price. I'll show you the graph in a bit. Alright. And last is called random variation (OR). Okay, so it means that there's a small error or blips in the data. Okay, that caused by chance. For example, if you sell hot dog, one day I might be the one who buy 10 hot dogs. So the demand go up by 10 for all of a sudden. Or the next day, nobody buy hot dog at all. And it just happened maybe once in a few weeks, alright, then that's okay too. So we have this error, you can have either small random. So you see that if the middle line is your trend line, you can see that this is called small error, small randomness. But if it's deviates so much from the center line, okay, this randomness is huge, okay, it has some meaning. So you have few cases when, so you look, that's why we always look at the trend line, okay, and see how the random behaves. A few examples. This is the chart of oil price over time from year 1995. So you see that it's go up for no reason from maybe 2000, around here 2003 until 2008. Okay, you can see it jump from $25 per barrel to 150. Right? So that's scary. And then it just dropped. Alright, and then it go up again, and then drop again, and now it's stay like this. So you see that? If I want to look at so this graph probably represents the cycle. If I have to forecast what's going to happen, because it's go up and then down. So basically, you want to watch the downtrend thing. Right. So if you think it's going to follow the same pattern, so when it drops a lot, it might go up a lot. So we are in at this point. Okay. So the question is it going to rebound to something here, or it's not going to rebound at all? Alright, so that we don't know. Right. But you see that in this case, we cannot find any seasonality because this cycle happened over several years. It's not like it happens every other year. Okay. But you can see that, of course, in this graph, you can see that there's a trend, right? You can draw something, right? You can see this is the upward trend, right? And then it's going to go down again. Okay. And all in this place, you can see that's an upward trend, even though it's up and down thing. Okay. This is what we call the trend line thing. So you see that's what's going to happen. So from here, we don't know what's going to happen here because is this 25 the low as low as it can get, or it can go lower. Right? So the oil price is scary. Okay. But if you follow the news, you see that every time PTT or Bangkok raise the price, it's going to raise the price for many days. It's so quick, but when they reduce the price, it's so slow. Right. That's weird. Okay. But if you follow the price, that's what happened in that case. Okay. So let's look at something else. Let's look at maybe Apple. Okay. So that's one stock price. Apple. Oh, okay. So see, this is the stock price of Apple over time. Okay, so it used to be around $12 per share. Now it's 100. Right? Oops. So that's much as you can get the data. So you see that? Of course, then this you can see the trend line. That is probably going to go up again. Right? So that's one of the price that go up. Let's see the stock price that it doesn't go anywhere that much. Maybe Walmart. So this is when we talk about that, it's pretty much constant during this period. Okay, that's why I said, if you forecast during this period, you will say that there's no trend. And then this is when it breaks the trend and it go up again. And so that sort of thing occur a lot. Okay, so when you see a lot of graph, you can see that I don't look at anything else. I only look at the fundamental of the graph. So I can see what's going to happen in the future. But of course, in theory, you can say anything I want, but in practice, making that decision is difficult. Okay? We're not talking about any other one. Okay, so we have Chinese student here. Let's look at the Chinese index a little bit. Where is that? Let's look at that's FTSE is not actually one, but that should be a good indication. So the stock price in China is scary also. So this is it's happened everywhere. This is what happened before that hamburger crisis, and then it's all dropped. It happened in every part of the world. Okay, you'd be surprised that you look at every stock index in the world during 2005, 2006, 2008. They're going to have the same pattern. Okay, because money go everywhere. Okay, and then it goes up and then it come down, but it's staying like this. Okay, so I don't know what's gonna happen, but we find out soon enough. Okay, so that's what's gonna happen. You think it's gonna go up again? Stock market in China, or you don't care at all? You have any money in investing in over there, or you invest all in this program now? That's where your money is. Okay, never mind. Okay, just sharing some idea. All right, so let's go back to this. Okay, so you see that all those graphs at the end, you want to try to see if you have anything like this. Okay, so first thing you want to find out is a trend. You draw the trend line. Okay, of course you have this kind of pattern. It's upward trend. Okay, and you look at the peak and the low. All right, and the peak and the low. If it occurs at the same time, you see that the low happened at the start of the year. Year 1, year 2, year 3, year 4. That's what we call seasonal peaks. You have this kind of peak, okay, high peak, low peak also, right? And then you have the average. So if you have this data that look like this, so in this word you can have upward trend. You have seasonality and there's some randomness also.